Hello and welcome back to the class of 5G. In previous lecture, we looked at the bold intent of 2G, but to fulfill them, strong actions were equally important. And first one of those actions was going digital. Calling going digital just an action might be underrated because it was beyond that, way beyond that. You can consider calling digital a movement. It was all about breaking free from the boundaries of analog communications nature and embracing the huge chunk of advantages and simplicity provided by digital. The process of communication was still the same though. User used to provide input voice to the mobile phone. Mobile phones would transmit modulated frequencies to the antennas. Antennas would return modulated frequencies for the receivers, and users would get demodulated output voice. But the magic was happening inside the cell phone themselves. Instead of just modulating or mapping the input voice to a higher frequency, mobile phones were performing much more complex set of tasks. The input data was digitized and then encrypted. Now what does that mean? Well, digitization or analog to digital conversion means turning the analog frequency or turning the analog input signal into a continuous stream of zeros and ones, or in other words, digital signal, by sampling it at a continuous rate and turning the analog values into digital. Whereas encryption means coding the digital data in a way that it becomes more secure from the user's end and more difficult to interpret for hackers. If you want to know more about different ways and means of A to D or analog to digital conversion and different methods of encryption, you can check out the visual guides in the resources section of this lecture. But if you are just satisfied with the fact that the input stream of data was turned into zeros and ones and then it was secured, we can move on. This meant that what user provided and what user got in return was the same thing as earlier: input voice and output voice. But cell phones and tower antennas were talking in digital language. They were speaking zeros and ones. And this was not a small feat. In fact, earlier I called it not just an action but a movement because naturally the previous phones or the 1G phones were not capable of performing this task whatsoever. Going digital meant users having to change their mobile handsets. And that was a big risk. What if users declined that? The mandate was necessary for everyone. And it was not just about the mobile communication. If you take other use cases as well, such as DTH, the transition between analog to digital always involved installing or purchasing new hardware. The genuine question is, why to go that far? As you already know, humans or anything natural speaks analog. But that's not the same for the towers. The frequencies generated by the antennas in the towers are artificial. They are generated by the inputs provided by circuits. And when we talk about circuits and artificial outputs, the more discrete and precise the frequency is, the better it will be interpreted. For the same user, going digital meant instead of transmitting a chunk of different frequencies in the analog band, the carrier would only transmit the data in zeros and ones. And one particular frequency will be assigned to 0, whereas the other one will be assigned to 1, and they will be far distant from each other, which means that zeros and ones won't get mixed up either. Within the same spectrum of frequencies, more users can be catered now because their dedicated bands are narrowed down. Typically, 2G frequencies ranged between 900 to 1800 MHz, which was way beyond 1G. So we had already enlarged the spectrum. We were prepared for more customers. Take this example into consideration. Let's say you have to transmit between 1 to 99 numbers and you are constantly throwing random number at a time. The one who is receiving might misinterpret some of the numbers and the final output of the stream of data might be different from what you intended to send. Instead of that, if you just have to send zeros and ones, it will be easier for the receiver to catch it even if you send it faster than normal rate. That is the core logic behind going digital. There are less chances to get confused between zeros and ones, and since the frequency of 0 and 1 are far apart from each other, transmission noise, reception noise, electronic error, everything can be nullified when interpreting the data. There are lots of advantages of going digital over analog. It starts with easier process and cheaper circuits. In terms of communication, you can cater more users. More users means easier scalability. It is easier to encrypt and encode digital information compared to analog, which leads to better security. It is more difficult for noise to penetrate the digital signal compared to analog, which means better quality of service is almost guaranteed. And just by going digital from analog, we are almost hitting all of the intents. This was the step taken in the proper direction. Industry was ready to cater more consumers. Industry was ready to scale. So the next problem was not about feasibility, it was about management. And to address that, we will talk about cellular approach in the next lecture. Till then, happy learning, and I hope you have a nice day.